a WikiVidi Documentaries production. Don't forget to like and subscribe. Enjoy. 1883 Eruption of Krakatoa. The 1883 eruption of Krakatoa in the Dutch East Indies began in the afternoon of Sunday, the 26th of August 1883, and peaked in the late morning of Monday, the 27th of August, when over 70% of the island and its surrounding archipelago were destroyed as it collapsed into a caldera. Additional seismic activity was reported to have continued until February 1884. Though reports of seismic activity after October 1883 were later dismissed by Rogier Verbeek's investigation into the eruption, the 1883 eruption was one of the deadliest and most destructive volcanic events in recorded history. At least 36,417 deaths are attributed to the eruption and the tsunamis it created. Significant additional effects were also felt around the world in the days and weeks after the volcano's eruption. Early phase. In the years before the 1883 eruption, seismic activity around the Krakatoa volcano was intense, with earthquakes felt as far away as Australia. Beginning the 20th of May 1883, steam venting began to occur regularly from Ketimbang, the northernmost of the island's three cones. Eruptions of ash reached an estimated altitude of 6 kilometers and explosions could be heard in New Batavia 160 kilometers away. Activity died down by the end of May, and there was no further recorded activity for several weeks. Eruptions at Krakatoa started again around the 16th of June, with loud explosions and a thick black cloud covering the islands for 5 days. On the 24th of June, a prevailing east wind cleared the cloud, and 2 ash columns could be seen issuing from Krakatoa. The seat of the eruption is believed to have been a new vent, or vents that formed between Ketimbang and Danang. The violence of the ongoing eruptions caused tides in the vicinity to be unusually high, and ships at anchor had to be moored with chains. Earthquakes were felt at Anya, Banten, and ships began to report large pumice masses to the west in the Indian Ocean. On the 11th of August, a Dutch topographical engineer, Captain H.J.G. Furtsenaar, investigated the Krakatoa Islands. He noted 3 major ash columns, which obscured the western part of the island, and steam plumes from at least 11 other vents, mostly between Danang and Krakatoa. When he landed, he noted an ash layer about half a meter thick, and the destruction of all vegetation, leaving only tree stumps. He advised against any further landings. The next day, a ship passing to the north reported a new vent, only a few meters above sea level. This may be the most northerly spot indicated on Furtsenaar's map. Activity continued through mid-August. Climactic phase. By August 25th, the Krakatoa eruptions intensified. At about 1300 hours on the 26th of August, the volcano went into its paroxysmal phase. By 1400 hours, a black cloud of ash could be seen 27 kilometers high. At this point, the eruption was virtually continuous and explosions could be heard every 10 minutes or so. Ships within 20 kilometers of the volcano reported heavy ash fall, with pieces of hot pumice up to 10 centimeters in diameter landing on their decks. Between 1800 hours and 1900 hours, a small tsunami hit the shores of Java and Sumatra, some 40 kilometers away. On August 27th, 4 enormous explosions occurred. At 5:30 a.m., the first explosion was at Ketimbang, triggering a tsunami heading straight at Krakatoa, now known as Banda Lampung. At 6:44 a.m., Krakatoa exploded again at Danang, with the resulting tsunami stretching eastward and westward. The largest explosion, at 10:02 a.m., was so violent that it was heard 3,110 kilometers away in Perth, Western Australia, and the Indian Ocean island of Rodrigues near Mauritius, 4,800 kilometers away, where they were thought to be cannon fire from a nearby ship. The third explosion has been reported as the loudest sound heard in historic times. The loudness of the blast, heard 160 kilometers from the volcano, has been calculated to have been 180 decibels. Each explosion was accompanied by tsunamis estimated to have been over 30 meters high in places. A large area of the Sunda Strait and a number of places on the Sumatran coast were affected by pyroclastic flows from the volcano. The energy released from the explosion has been estimated to be equal to about 200 megatons of TNT. roughly 4 times as powerful as the Tsar bomber, the most powerful thermonuclear weapon ever detonated. At 10:41 a.m., a landslide tore off half of Krakatoa volcano, causing the final explosion. Final explosive eruption. The pressure wave generated by the colossal fourth and final explosion radiated out from Krakatoa at 1,086 km per hour. The eruption is estimated to have reached 310 decibels, loud enough to be heard clearly 5,000 kilometers away. It was so powerful that it ruptured the eardrums of sailors 40 miles away on ships in the Sunda Strait, and caused a spike of more than 2 + half an inch of mercury in pressure gauges 100 miles away, attached to gasometers in the Batavia gasworks, sending them off the scale. The pressure wave was recorded on barographs all over the world. Several barographs recorded the wave 7 times over the course of 5 days, 4 times with the wave traveling away from the volcano to its antipodal point, and 3 times traveling back to the volcano. Hence, the wave rounded the globe 3.5 times. Ash was propelled to an estimated height of 80 kilometers. The eruptions diminished rapidly after that point, and by the morning of the 28th of August, Krakatoa was silent. Small eruptions, mostly of mud, continued into October 1883. By then, less than 30% of the original island remained. Effects. The combination of pyroclastic flows, volcanic ash, and tsunamis associated with the Krakatoa eruptions had disastrous regional consequences. Some land in Banten, approximately 90 kilometers south, was never repopulated. It reverted to jungle, and is now the Ujung Kulon National Park. The official death toll recorded by the Dutch authorities was 36,417. The burning ashes of Ketimbang. Verbeek and others believe that the final major Krakatoa eruption was a lateral blast, or pyroclastic surge. Around noon on the 27th of August 1883, a rain of hot ash fell around Ketimbang in Sumatra. Approximately 1,000 people were killed in Sumatra. There were no survivors from the 3,000 people located on the island of Subsea. There are numerous documented reports of groups of human skeletons floating across the Indian Ocean on rafts of volcanic pumice and washing up on the east coast of Africa, up to a year after the eruption. Tsunamis and distant effects. Ships as far away as South Africa rocked as tsunamis hit them, and the bodies of victims were found floating in the ocean. For months after the event, the tsunamis which accompanied the eruption are believed to have been caused by gigantic pyroclastic flows entering the sea. Each of the 4 great explosions was accompanied by massive pyroclastic flows resulting from the gravitational collapse of the eruption columns. This caused several cubic kilometers of material to enter the sea, displacing an equally huge volume of seawater. The town of Merak was destroyed by a tsunami 46 meters high. Some of the pyroclastic flows reached the Sumatran coast as much as 40 kilometers away, having apparently moved across the water on a cushion of superheated steam. There are also indications of submarine pyroclastic flows reaching 15 kilometers from the volcano. Smaller waves were recorded on tidal gauges as far away as the English Channel. These occurred too soon to be remnants of the initial tsunamis, and may have been caused by concussive air waves from the eruption. These airwaves circled the globe several times and were still detectable on barographs 5 days later. Geographic effects. In the aftermath of the eruption, it was found that the island of Krakatoa had almost entirely disappeared, except for the southern third. The Krakatoa cone was cut off along a vertical cliff, leaving behind a 250 meters deep caldera. Of the northern 2/3 of the island, only a rocky islet named Bootsman's Rots, a fragment of Danaan, was left. Poolskihode had totally disappeared. As a result of the huge amount of material deposited by the volcano, the surrounding ocean floor was drastically altered. It is estimated that as much as 18 of ignimbrite was deposited over an area of 1,100,000 square kilometers, largely filling the 30-deep basin around the mountain. The land masses of the Leighton and Lang Islands were increased, as was the western part of the remnant of Krakatoa. Much of this gained material quickly eroded away, but volcanic ash continues to be a significant part of the geological composition of these islands. 2 nearby sandbanks were built up into islands by ashfall. but the sea later washed them away. Seawater on hot volcanic deposits on Steers and Kamea had caused steam to rise, which some mistook for a continued eruption. Global climate. In the year following the 1883 Krakatoa eruption, average northern hemisphere summer temperatures fell by as much as 1.2 C change. Weather patterns continued to be chaotic for years, and temperatures did not return to normal until 1888. The record rainfall that hit Southern California during the water year from July 1883 to June 1884, Los Angeles received 38.18 in, and San Diego 25.97 in, has been attributed to the Krakatoa eruption. There was no El Niño during that period, as is normal when heavy rain occurs in Southern California, but many scientists doubt that there is a causal relationship. The Krakatoa eruption injected an unusually large amount of sulfur dioxide gas high into the stratosphere, which was subsequently transported by high-level winds all over the planet. This led to a global increase in sulfuric acid concentration in high-level cirrus clouds. The resulting increase in cloud reflectivity reflected more incoming light from the sun than usual, and cooled the entire planet until the suspended sulfur fell to the ground as acid precipitation. Global optical effects. The 1883 Krakatoa eruption darkened the sky worldwide for years afterwards, and produced spectacular sunsets throughout the world for many months. British artist William Ashcroft made thousands of color sketches of the red sunsets halfway around the world from Krakatoa in the years after the eruption. The ash caused such vivid red sunsets that fire engines were called out in New York, Poughkeepsie, and New Haven to quench the apparent conflagration. This eruption also produced a bishop's ring around the sun by day, and a volcanic purple light at twilight. In 2004, an astronomer proposed the idea that the blood-red sky shown in Edvard Munch's famous 1893 painting The Scream is also an accurate depiction of the sky over Norway after the eruption. Weather watchers of the time tracked and mapped the effects on the sky. They labeled the phenomenon the equatorial smoke stream. This was the first identification of what is known today as the jet stream. For several years following the eruption, it was reported that the moon appeared to be blue and sometimes green. This was because some of the ash clouds were filled with particles about 1 micrometer wide, the right size to strongly scatter red light, while allowing other colors to pass. White moonbeams shining through the clouds emerged blue, and sometimes green. People also saw lavender suns and, for the first time, recorded noctilucent clouds. Brought to you by WikiVidi Documentaries. Would you like to know more?